Okay, so question 10 then. Question 10. We have a hotel room that has 4 rooms. So each room I'm going to draw as a box. So 1, 2, 3, and 4. So each room, so room 1, room 2, room 3, room 4. Okay? Now each room can accommodate a maximum of 4 people. So in other words, we can only put 4 people in each room because there's not enough beds in the room otherwise. People will be sleeping in the bath, right? Or something like that. Okay? How many different ways are there of putting 6 people in the 4 rooms? So we have 6 guests, we have 6 people, and we need to put them into these 4 rooms, okay? Now, bearing in mind the condition that each room has to have a maximum of 4 people, how many different ways could we do this, okay? Now, this is how I thought about it. Has anybody got any ideas, first of all? Anybody got any ideas? N would be 16. So the maximum number of rooms. So the maximum number of guests, if you put 4 people in each room, would be 16. Is that what you're saying? Yeah, I definitely agree with that. But how does that help putting these 6 people in there? Okay, just because we're running short on time slightly, can I talk you through how I thought about it? Okay. So sometimes when you get faced with quite tricky situations, okay, is to maybe think, well, what's making the question tricky? Are you happy that what's making the question tricky is the fact that we've got this maximum of 4 people in each room? Yeah? So why not think about the situation, first of all, by removing that restriction? By basically saying, well, what if we could put as many people as we like in each room? How many different ways are there of doing that? So let's first of all think about it without restriction. In other words, we can put as many people as we like in each room, okay? Now, I kind of thought about this as we've got 2 things that we need to do here. First thing we need to do is we need to pick a person. So in other words, we need to pick a person from this group to put in a room, okay? And then what we've got to do is pick a room. So really it's a 2-step process. First of all, we've got to work out how can we pick a person. Then we've got to work out how can we pick a room for that person to go in, okay? So as an example, okay, let's think about these 6 people separately. So let's say we've got A, B, C, D, E, F, and G. So this is each person. So Alice, Bradley, Charlie, David, Edward, Fiona, and Georgina, right? So these 6 people. Thank you. Thank you. Okay, so let's see first of all how many ways there are of picking one person. So picking person A, okay? Let's say Alice, right? So we've got to do 2 things to this person. First of all, we've got to pick them. Now I'm going to write it slightly weirdly, and you'll see why later. You'll see why in just a second, okay? So effectively what I'm saying is we need to pick that person. Well, there's one way of picking that person, okay? So there's one person there, and we want to pick him, okay? 1C1. You'll see why I'm writing that in just a second, okay? Then I've got to pick a room for that person. Now remember, at the moment, I'm considering it without any restriction, okay? So would you be happy 4C1 ways of choosing that room, okay? And actually, for the next person, it's going to be exactly the same. We pick that person, then we just pick any room for them to go in. And the same thing here. And the same thing here. And the same thing right the way down to, in fact, 1C1. So in other words, what we can think of is we've got this, and this. Just think, first of all, how are we going to combine all of this together? Yeah, exactly, because we want this, and this, and this, and this. In other words, it's all going to happen. So it's going to happen simultaneously, so therefore it's an and situation, okay? So in other words, we're going to have 1C1 multiplied by 4C1 all raised to the power of 6, because I'm going to end up multiplying all these together. It's the same thing being multiplied by itself 6 times. No, yeah, so basically we just got the same thing 6 times and we're doing it simultaneously. Now if you do this, I think it's 4,091, I think, from here, okay? Now just very quickly, because we're running out of time slightly, this is without restriction. So in other words, if we were just going to choose these people and put them into 4 rooms without any restriction on the rooms, there'd be 4,091 ways of doing that, okay? Now what we need to do is go back and think about the restriction. Now, to be honest with you, I'm not going to go through and think about all the restrictions which we could have and all the different ways we could do this. I'm going to think about the complement. Now, this is a really useful idea in probability. If you think about the situation you don't want, sometimes that will work out quicker. So because we have the total number of ways of arranging people or choosing people, okay, if you think about the complement situation, the situation you don't want, then if you take that away from this, you'll be left with the situation you do want. Does that make sense? Right? Okay. So let's just think then, if there's max of 4 people in a room, what 2 things can't we have? Exactly, we can't put 5 people in a room and we can't put 6 people in a room. So that's all we need to think about. And then we can take it away from this and we'll be ending up with what we want. Okay? So if we just think, how many different ways are there of getting 5 people in a room? Okay? Then if we think, how many different ways are there of getting 6 people in a room? Take those 2 things away from this and we will be left with what we want. Okay? So how many different ways are there of getting 6 people in a room? Well, first of all, we've got 6 people and we're going to choose all of them. So we're going to pick a person. We're going to choose all 6 of them. So we're going to end up with 6 choose 6. And then we just need to choose a room for them to go in. So would you be happy? 4 choose 1. Pick all 6 people, put them in a room. Okay? Right? If you think about 5 people in a room, okay? Well, let's think about it. First of all, you've got to have 6 people that you're choosing from, and you're going to choose 5 of them, okay? Then you're going to pick a room for them to go in. However, then, how many people are left? 1 person. 1 person didn't get chosen over here. So would you be happy? You then need to pick that person, and then you need to choose a room for them to go in. But how many rooms are left? 3, because you've already put the rest of the people in the 1 room. So then you're going to multiply that by 3 choose 1. And then because you want both of these things to happen, so you want this to happen and this to happen, you're going to multiply. Is that okay? So I think the number of ways of doing this, and it's gone off the screen, is like 700 and something. Okay? The number of ways of doing this, so this is 72. So there's 72 ways of putting 5 people in a room. There are 4 ways of putting all 6 people in a room, fairly obviously. Okay. So therefore, if you take this, the total number of ways you could have, which is 4,091, take off what you don't want, which is 5 people in a room, or 4 ways. Okay, so 5 people in a room or 6 people in a room. Okay, then you'll be left with what you want.
4,096.
Is it 4,096? Yeah. That's fine. So I was reading the wrong solution up there. Good, thank you. Then you'll be left with what you do want, which is going to be, is it 4,020? Yeah, 4,020. So there you go. Okay. Thinking about complements is a really useful idea. Think about complements. First of all, start off thinking about the situation where there's no restrictions, then take off what you don't want, and you'll be left with what you do want. So you don't want 5 people in a room, you don't want 6 people in a room. Take that off, you'll be left with what you do want.